Hello, Krashimir Nemets here from InfoSim. Today I want to show you a use case in this session when we will see how we can get from data to decisions, having different mobile equipment vendors and seeing how we lead or how we join the data together to enable the C-level management to make decisions. So imagine you are a network operator, mobile network operator, sitting in your network operation center. You're seeing your base stations. They are performing well. They're having a lot working fine, except some minor issues. And then something quite unexpected happens. For example, there is a huge increase in rainfall, which basically leads to a significant outage of several base stations. So this is completely unexpected event. And of course, your manager or even C-level comes to you and says, give me the real-time reports, which base stations are performing well, which are having a significant impact from this rainfall, which are not operating, and so on and so on. And basically, when you have multi-vendor network environments, you have usually the element managers and network management systems from different vendors with a lot of data. But can you really get a unified view of your network operational status if each vendor is using different methods to calculate the availability? So basically, you lack the unified view of base station operational status due to very specific vendor data. They're usually locked in, they're not joined together. So you have fragmented base station performance information. What you also have is inconsistent base station availability and capacity insights. So you, or let's say the function of mobile network operator, is also to ensure consistent mobile coverage and capacity planning. But if the availability reports are completely separated by different vendors, you missed that joint or normalized data. You basically lack the real-time insights, which base stations are underperforming, are at risk to fail. It's quite difficult because each of those vendors can hide or can have vendor lock-in and can have customized or very isolated vendor data system. So without that data, you're not able to deploy AI-driven predictive maintenance. And also, last point, which is very important today, is energy and infrastructure management. So as energy consumption is major OpEx driver, yet power usage metrics from different base station vendors are completely siloed. So without a holistic view of that energy efficiency and site conditions, we cannot do any sort of power savings or implement smart energy management, which also leads to higher operational cost and sustainability challenges. So idea here is basically, while there are multiple infrastructure management systems, each taking care of its own specific elements or specific domain, it is quite hard to reach the management view, so outside in view, which would be in a way very simplified, doing some sort of synthetic status report. So abstracting the lower layers and basically just conveying the information which is needed on the management level. So in that sense, having a single unified overview of mobile base stations brings or accomplishes a lot of business and operational goals. So it gives a comprehensive near real-time visibility into mobile base station health, agnostic of vendor. So we are breaking the silos between vendors. We are giving the management view on the operational mobile network health. We can quickly identify and locate the problematic base stations, and we can drill down to any level of detail which is required. We can also integrate seamlessly with the various vendor element systems and domain controllers and all systems, because only then we will know the overall status. I mentioned here rainfall. This is the situation that happened in several countries last year, and really there were huge outages of mobile networks. Then, without knowing the amount of rainfall or changes in temperature, it's quite difficult to have the overall prediction or insights what could happen. So we also integrate environmental data such as temperature and rainfall. We also use the integration with ticketing system and work order management system to track the operational activities on the field. And on the same dashboard, we can also provide the access to the documentation, which helps people to get more insight what the problem could be. This is the example of the base station overview. So we can see on the left side, we have a map, a country map, which represents the mobile base stations grouped together by location. They always carry the synthetic health status, major, meaning there is a major impairment. And if there is at least one base station in the group will be colored red. There are also minor and warning statuses. And if it's green, everything is okay within this group of base stations. On the right side, we also see the control in which we can dynamically select the region, service status, vendor generation, basically any parameter that we would like to use filter on when we are selecting the base stations. If we want to go and list more details for each base station, we have a different dashboard, which basically represents how it's structured, what kind of alarms are opened on the sub-interfaces or subsystems, what is their severity, is the ticket opened. We see different graphs coming from different systems, which are integrated together into this single dashboard. Now I'll show it exactly on live system. So as an overview page, we do see the amount. There are approximately 5,000 base stations here in this use case. For example, I'm in charge of Bavaria region, so I want to go a little bit deeper just to have the data from that region. I want to see all the base stations that are in major service status. Maybe let's check Nokia base station or Ericsson base stations and those that are serving 4G technology. So at the end, I see there are two base stations that have major alarms. They're listed on the bottom right side with their details. So I know which is vendor, which is the base station model, generation, serial number. So by clicking on the base station, I can go and find out more about it. So I do see each of those subsystems. Does it have any specific alarms? What is the severity? Is the ticket open? So by clicking here, I would go directly to the ticketing system. or by clicking here, I would go to the field team management system to see is my field team or subcontractor team doing some operational activities on the site itself. On the right side, I can see the alarm trends. So weekly, basically weekly movements of alarms. So I can check if there are some significant changes. On the bottom side, or on the this graph specifically, I track the service availability of this base station. So I do see other days were okay, but there is some non-availability percentage on Sunday. So there's something happening on Sunday there. I can use the same dashboard to represent the inside and outside temperature on the site, and as well use to show the rainfall for this region or this specific location. So for example, temperature data can come from IoT sensors placed on the base station, and rainfall can come from public services. So it can be either prediction or real measurement. So we can easily show here the environmental conditions. Two lower graphs basically show the usage. The left one are the measurements derived from the base station itself. So the voice traffic in Erlangen. So what's the actual base station usage or number of calls on the base station? And as well the power consumption in kilowatt hours this base station consumes. Usually those things are quite related together. On the right graph, I demonstrate and show the usage or utilization of IP MPLS links. Let's say we do have two 10 gigabits per second links, which with maximum bandwidth of 20. And I can easily show the input and output direction, so utilization. So I'm quite safe here. I still didn't reach the maximum bandwidth available for this base station. But what is also a capability is integrating other data sources. Let's say we do have TVAMP probes, which are running from a packet core to the base station and reflecting back. So on the same graph, I could display delay and jitter values. So I have exact measurement from the base station to the core elements of mobile network. So this is the flexibility that we can have. Of course, each of those parameters could be further expanded with the new dashboard, so we can go as deeply as we need. Okay, that's it from my side. Thank you. Thanks everybody for joining, and I hope you can really utilize your StableNet installations to the maximum.